Okay, now we are on some new notes for division properties of exponents day 2. On the first slide, you're going to see that now I have exponents that are negative. We talked about this idea before on Tuesday. If you look back at that worksheet on Tuesday where we looked at patterns in exponents, it actually had 3 in it, which is why I chose the top ones. And you kind of saw a pattern in what negative exponents meant. Negative in math very often means inverse. The opposite, if you're moving to the right on the x-axis, +5, -5 would be the opposite way. The opposite of adding is subtraction. So negative exponents here do not mean make the number negative. It means instead of repeated multiplication, we're repeatedly dividing. So dividing is the same as multiplying by a fraction. If I said take 10 and divide it by 2, you would say 5. If I said take 10 and multiply it by a half, the answer to that is 5. It's actually called the definition of division. It's the same as multiplying by the reciprocal. So if you can find that worksheet from Tuesday, you can take that out to help you fill in this top row here. If you were not here on Tuesday, the teacher should have a copy, or you can use someone at your tables. Once you fill out this first row, look for a pattern to help you be able to rewrite these without negative exponents, just like I did here. I took 3 to the -2nd and I rewrote it without a negative exponent. Try that in the second row. In the third row, go step by step. Rewrite just the bottom part of the fraction without a negative exponent, and then you may need to check back in with me, but give it a try. What I would suggest is this. For these two in the bottom row, put it into your calculator, okay? 1 divided by 2 to the -2nd, and press enter. See what the answer is. Do the same thing on this one in your calculator. See what the answers are. You might be able to figure it out. Don't worry, I'll show you in the next one too. So in your groups, I'd like you to finish this slide. Please push pause now. Okay, across the top, you can see, and again, all of this idea came from what we did on Tuesday. Negatives are repeated division. I'm going to take 1, I'll divide it by 3, then I'll divide it by 3 again, which is 1/9. So I saw that every time I had a negative exponent, it basically made that be 1 over that number. 1 over 3 squared, 1 over 3 cubed, 1 over 3. And we also talked about this one, 3 to the 0 power. So that anything to the 0 power equals 1. If you want to see it in kind of a rule way, if I had 3 divided by 3, that would equal 1. And you're going to see that come up a little later in some examples. I'll get into that more. But important here, negative exponents mean repeated division. Just move it to the denominator, and then you can simplify. Anything to the 0 power is 1. It is not 0. And again, we talked about that on Tuesday. Big mistake I see is people saying that's 0. Now, for your last 3, you're going to see I move on to 2 slides. I didn't have enough room for all the answers here. So the first thing I did, it's funny, I'm pointing at the screen, but you can't see that, is 2 to the -2nd is 1 over 2 squared. So you see how I did that there. Just worried about the denominator. Now I have 1 divided by 1/4. Okay, 1 divided by 1/4. Well, that's weird. It looks weird to have a fraction and a fraction. So to make the denominator equal to 1, I said, okay, what do I have to multiply 1/4 by to get 1? 4. So I multiplied top and bottom by 4. 1/4 times 4 is 1. 1 times 4 is 4. 4 divided by 1 is 4. I also rewrote 4 as 2 squared. The reason I did that is to hopefully help you make a connection. So look at this again. I started with 1 divided by 2 to the -2nd. My final answer was 2 to the +2, like on top of the fraction. I have more. So over here I did the same thing. You can see the denominator. I just worked with that with the negative exponents I had done earlier. So I made that 1 over 3 to the 3rd. I simplified that as 1 over 27. Looks kind of weird, a fraction and a fraction. So I said, okay, what can I multiply 1/27th by to get a whole? 27. I multiplied the top and bottom by 27. I got 27 over 1, which equals 27. And again, I rewrote that as 3 to the 3rd. So again, 1 over 3 to the -3 ended up as 3 to the +3. look for patterns. You can see I did that here with the x's using that same idea. So I think you can probably figure out a pattern if the x has a negative exponent in the denominator, kind of what makes that positive. So if we look back here, if it was a negative exponent over 1, we don't usually write over 1, but over 1, if I move it to the denominator, the exponent becomes positive. If the exponent is negative in the denominator, it will, to make it positive, I can move it to the numerator. All right, so I have some examples here. In the first one, you can see that I did it in 2 ways, just like I did yesterday's notes, where I have the red being the expanded form. I divided the c's. You can see that, and c divided by c is 1. That's an idea we talked about yesterday. And I am left with c squared. Where are those c's? Are they in the numerator or the denominator? In the denominator. 1 times 1 times 1 is 1. C times c is c squared. Now, we talked about division rules yesterday. I also know that if I didn't want to do expanded form, I could subtract the exponents. So both are c. So if I do 3 minus 5, I get c to the negative second. Then, based on what I saw on the first slide, I can rewrite that as a positive exponent by moving it to the denominator. So the blue and the red have the same answer. It's 2 different ways to do it. So what I'd like you to do is work in your groups on these examples. You can do the red for all of them if you want, or you can do the red for some and try to use some rules for the blue. Go back and forth. When I show you the answers, I will have both versions. I'm hoping at some point you might kind of be able to move to the blue a little more, just to save you a little time. So please push pause now. All right, over here, you'll see the answers. Again, you can push pause if I'm going too fast. Over here, x to the 0 is 1. So I didn't even bother. I just said, oh, anything to the 0 is 1. I'm going to replace x to the 0 with 1. I wrote the 7x's in the bottom. I said, oh, what do I have left? I have 1 on the top, x to the 7th in the bottom. If I subtract the exponents, I get x to the negative 7th, and that's there too. All right, a by itself is a to the 1. Okay, it's 1a. You can kind of see that there. So I did it in expanded form, and then I did it with the rule here. This one I know gets a little crazy in the red, but again, I said, okay, if it's a negative exponent, I'm going to write it as a fraction, 1 over x to the 3rd. That's all I did right there. And again, this is the problem I had before. Oh, wait, I have a fraction and a fraction, just the fractions on the top now. So I said, okay, how can I make this a whole? Well, if I multiply it, x cubed divided by x cubed is 1. So I multiply top and bottom by x cubed. I got x to the 6th. If you use the rules, it works out as well over here. Okay, over here, again, I have x to the 5th. I rewrote my negative exponent as a fraction. When you multiply fractions, you multiply across the top and the bottom. I went to expanded, got x squared. When I'm multiplying, I add exponents. I did the same thing here. Over here, rewrote them as fractions, multiply across the top, multiply across the bottom, add exponents. And then here it is using the rules. These are the last 3. I couldn't get them all on one slide. Again, you can see expanded form, and you can see the rules in blue, just as a kind of combination. You're not going to have to write every single step. I know some of you are going to work kind of in a combined approach, but I want you to see both so that it makes sense. It's not a trick. It's, oh, that makes sense if I go to expanded form. Over here again, just wanted to point out, I've d to the 0. I said, oh, wait, anything to the 0 is 1. So I just replaced the d to the 0 with 1. That's where that 1 came from over there. All right, so again, push pause. If I go too fast, you can always rewind. All right, here is, I apologize, another set. Okay, when I show these answers, I'm not going to do the red and the blue for every single one. Work through these. You do what you need to do. Go to expanded form, use rules, talk with people in your group to see what's working. So we're going to push pause and try those now. Please push pause. Okay, shrink this up a little bit. All right, here are your final answers. Again, you can get them in many different ways. Make sure you go -3 minus 4, that's r to the -7. Make sure you're squaring the 3 here. So when I got to here, I said, okay, 3, you have a positive exponent. You get to go to the top of the fraction. X, you have a negative exponent. You go to the bottom. And that's how I got there. In this one causes a lot of problems. If you use the rules, -3 minus a -3 gives you x to the 0, which is 1. But also, look, I'm dividing something by itself. Anytime I divide something by itself, it equals 1. All right, over here, you'll get b to the 0, which is 1, or if you went to expanded form, you'll see them all divide out. Over here, I multiplied the exponents, so -2 times -3, that's where the positive 6 came from. -2 times 4 is -8. Again, x, okay, you have a positive exponent. All right, you get to go to the top of the fraction. Y, you have a negative exponent. You move to the bottom. All right. The last one, I did 15 divided by 3. I got 5, okay? And that's like 5 to the first power, positive 1. I subtracted the exponents here and did the same thing. Okay, 5, you're to the positive 1. So 5, you get to go to the top, a to the 4th to the bottom. Or you could also think of this as 5 times 1 over a to the 4th. And you would get the same answer. Okay, here's your next set of problems. Give those a try. Again, try to work with each other. Explain. Look at your different answers. The more you talk about it, the deeper you will learn it. So please push pause now. And these are the answers for that. Again, 6 divided by 12 is 1/2. So if you just kind of look at that as its own problem, over here I use the rule. I think you can figure that. Over here, I knew if I had y over x written 3 times, that would give me 3 y's on the top, x cubed here. Notice that first fraction did not change. Over here, I just rewrote the bottom. You don't have to do that. A lot of you are going to say, Mr. Humphrey, I don't need that. I just wanted to put the x's under each other and the y's. It's okay if you don't. And you'll end up here whether you go expanded form or rules. In this problem, you'll see x over y to the 0. Excellent. Oh, it's to the 0. I replaced it with a 1. That's all I had to do. Didn't need to do anything else, so I replaced it with a 1 and went there. Over here, again, if you go to expanded form, you would see, so 3 times 6 is 18. 3 times 2 is y to the 6th. 5 times 4 is 20. 3 times 5 is 15. And you can almost visualize this. Okay, I have 18 x's on the top and 20 x's on the bottom. If I divide those out, where are the leftover x's going to be? On the bottom. How many will there be? 2. 6 y's on the top, 15 y's on the bottom. Okay, if I start to divide them out to be 1, I'm going to be left with some. Where will they be? On the bottom. How many? 9. So that's where that came from. Over here, most common mistake is I see that you don't cube the 2 or the put 2 to the 4th. So just be careful. Remember, it's this whole thing written 3 times in a row. I left 2 to the 3rd and 2 to the 4th because they both have a base of 2. So I can do exponent rules there instead of multiplying that out. I know it's not that hard if you multiplied it out, though. Again, 3 t's on the top, 8 t's on the bottom. Kind of visualize that. And you will get this answer. So the video is here. Go back, rewind, pause, whatever you need. The homework is in today's announcement.